Hello and welcome to BioRules video lessons. Today we are going to be talking about energy again, but focusing on the energy transfer and energy transfer efficiency. So, energy pyramid. You have grass or a producer, lots and lots of energy in there. And for the next trophic level, in this example here, the hair, the energy that's passed is only about 10%. So you're going to be having the next trophic level much less energy. And for the next trophic level, in this example here, the lynx, we are going to have only about 10% of energy passing, so we are going to have also less energy in that trophic level. This is the nature of energy transfer in ecosystems. Energy is always being lost as heat in every trophic level, so we have less and less energy available in the next trophic level. So why are we talking about that? Because we're going to be talking about energy efficiency in terms of crops for human consumption. So if you have corn, for example, feeding a vegan, a person that is strictly vegetarian, so that hypothetically in this case here needs 1 kilogram of food every day to build its body, this person to make 1 kilogram of food is going to be needing to eat 10 kilograms of plants, represented here by corn. So 10 kilograms of corn would be necessary to make 1 kilogram of a vegetarian person. Okay, this is how it goes. Because of the 10%, you already got this idea, I hope. But what if we have a carnivore? What if we have corn feeding chicken, feeding a carnivore? And this carnivore also needs to build 1 kilogram of body per day. So in that case, this carnivore is going to be needing 10 kilograms of chicken because energy lost and 10% passes and so on. So we're going to be needing 10 kilograms of chicken. And those 10 kilograms of chicken, to make 10 kilograms of chicken, you're going to be needing 100 kilograms of corn. So in terms of energy efficiency, having an intermediate here in the process like the chicken is not so efficient. Because when you have the intermediate, then you will spend 10 times here, 10 times there, you increase the amount of energy necessary in the beginning for you to be able to make the same amount in the end. So you need 10 kilograms to feed a vegan, you need 100 kilograms of corn to feed a carnivore that eats chicken that ate corn. On the other hand, some feeding relationships that we have, some carnivores, they eat animals like cows or cattle that they may eat plants that we don't eat. So cattle that's growing on grass, they are eating grass that we don't eat. So in that case, they are still going to be needing 100 kilograms to make 10 kilograms of cow, to make 1 kilogram of a carnivore. But we don't care much about the grass because we don't eat grass. So let the carnivores to eat cows that ate grass. If they did eat something that we do eat, like soybeans, for example, then it's another story. Then the intermediate would reduce the efficiency as well. When you're talking about efficiency, there is one calculation that should be made called feed conversion ratio. Basically, how much food we need, how many kilograms of food that we give to an animal to make 1 kilogram of edible, eatable weight. So this varies according to the culture, that varies according to the animal you're talking. So when you talk about cattle, we need about 10 kilograms of food to make 1 kilogram of edible weight every day. So the cat is not very efficient in this conversion, so you need this 10 kilograms to make 1 kilogram. If you talk about other culture like pigs, for example, pigs, they need less. They need a little bit less than 5 kilograms of food to make 1 kilogram of pig. And if you talk about chicken, even more efficient, we need about 2 or 3 kilograms of food to make 1 kilogram of chicken. However, this is the mass that was fed to make live weight of the animal, but we don't eat the entire animal. So another thing that should be taken into consideration here is the percentage of the animal that's edible for us. In the case of cattle, about 40% of cattle is edible to us. So if you need 10 kilograms to make 1 kilogram of living cattle, if you take out the other 60% that are non-edible, actually we need about 25 kilograms of food to make 1 kilogram of edible cattle. So actually you need 25 kilograms to make 1 kilogram of food for us if you're eating cattle. On the other hand, if you're going to be eating pigs, we eat about 55% of the pig. So in that case, the amount of feed necessary to make 1 kilogram of edible pig is around 10 kilograms. So you need to feed 10 kilograms to the pig to make 1 kilogram of meat for us. And the chicken is even more efficient. The percentage edible is more or less same, 55%, but because you need a smaller initial, the pig you need less than 5%, less than 5 kilograms of feed to make 1 kilogram of edible chicken. Yay, that's good. So in terms of efficiency of feed conversion ratio, if you want to produce more food, it's better to produce chicken than pig, and it's better to produce pig than cattle. But if you really want to go for very, very high efficiency, there is another animal that can be put into this equation. Insects. Insects, they have a very small feed conversion ratio. You need less than 2 kilograms of feed to make 1 kilogram of living insects, and 80% of the insect biomass is actually edible. So in that case, you need about 2 kilograms of food to make 1 kilogram of insect. Very, very efficient. So in terms of proteins, if you want to be feeding humanity, the more efficient animal to be growing would be insects. Okay, you need about 25 kilograms to make 1 kilogram of cattle. You need 9 kilograms to make 1 kilogram of pig. You need about 4 kilograms to make 1 kilogram of chicken, but you need less than 2 kilograms to make 1 kilogram of insects. So if you're into this idea of eating animals, so maybe eating insects is going to be much more efficient and we will be able to feed much more people. Now we have a little questionnaire here to see if you got the idea of the feed conversion ratio. I hope you had fun.